In lesson 4-2, we'll be talking about proportional and non-proportional relationships. So first, we'll talk about what does the words proportional and non-proportional mean. When we see or say the word proportional, we need to be thinking equal or equivalent. So if something is proportional, they're also equal. Like 1/2 is proportional to 2/4. So non-proportional just means not equal. So again, if I say the word proportional, that basically means are the two equal or equivalent? So write equivalent or proportional ratios to the ones given. So a proportional ratio to 3/4 would be 6/8, or we could have 9/12, or we could have 15/20, or you could do a factor of 10 and say 30/40, or 300/400, and we could continue this for quite a while. So again, these are all proportional to 3/4. 3 is to 4, just like 6 is to 8. So again, equivalent and proportional mean the same. So 1/2 would be 3/6, and 20/40, and 50/100, and we could continue that list on. So here we could have 21/24, 49/56, and we could say 70/80, and again we could continue that list for quite a while. So again, we're thinking of those proportional relationships. All of these fractions are proportional. If I wanted to simplify this ratio, it would simplify to 7/8. If I wanted to simplify 50/100, it would simplify down to 1/2. So they would all be equal. So when we're thinking of using proportional relationships and talking about them, here's a word problem. A house cleaning service charges $45 for the first hour, and then $30 per hour for each additional hour. And the service works for 4 hours. So they want to know, is the fee proportional to the number of hours worked? And then they want us to make a table. Well, whenever we're making a table and we're talking about ratios and rates, it's important for us to get in a habit. We always like to put money on the top and time on the bottom. So in this case, we do have money, so we're going to put it on top, and we do also have time. It's hours. Time could be hours, days, second, months, years, weeks. Anything that has to do with time, we're going to typically try to put those numbers on the bottom. If it has to do with money, we'll put it on the top. Sometimes you won't have either, and you'll just have to decide where you're going to put things. But if you ever have money, try to get it on top. If you ever have time, put it on the bottom. Just like miles per hour, we're going to think per time, per hour, per second, per minute, those sorts of things. So here, for the first hour, we're going to do $45 for 1 hour, and then we're going to add $30. So that's going to be $75 for 2 hours, and then we're going to have $105 for 3 hours, and $135 for 4 hours. Well, we see that it's 45/1, and that's the ratio. Well, the question is 75/2 an equivalent ratio? Are they equal? Well, that answer is no, because we would need it to be 90/2. So therefore, since even one of these situations is not equal, we're going to say that this is non-proportional. So this relationship, because the first hour is different, this relationship is non-proportional as an equation or relationship in any way, shape, or form. A recipe for jelly frosting calls for 1/3 cup of jelly and 1 egg white. So just because this is dealing with 1, and it's kind of a unit rate, I'm going to put the 1 on the bottom for egg whites, and I have 1/3 on the top. So for 2 egg whites, I know I'm going to have 2/3 cups of jelly. For 3 egg whites, I'm going to have 3/3 cups, and I'm just going to leave it in that form rather than switching it to 1 whole cup. I'm just going to write 3/3, and then 4 egg whites, I'm going to have 4/3 of a cup. Now in this case, if I were to simplify this down to be one egg white, I would get 1/3. So these are actually equivalent ratios and equivalent statements, because it's not like the last problem. The last problem I started with more, and then I tapered it down to $30 adding. Whereas this problem, I started with 1/3, I'm adding 1/3, I'm adding 1/3, I'm adding 1/3. So this actually is a proportional relationship. And then this is our proof here. Our table is our proof. It says make a table of values to explain your reasoning. So you're going to want to make a list or make a table to help explain your answer. It's kind of how you show your work, and then proportional is your actual answer. To convert a temperature in degrees Celsius to degrees Fahrenheit, multiply the Celsius temperature by 9/5 and then add 32 degrees. So if you have a Celsius temperature, you're going to multiply it by 9/5, and then you're going to add 32 degrees. So I'm just kind of making an equation here. Here's your Celsius temperature, and that's going to give you your Fahrenheit temperature. Well, for the sake of this problem, I'm just going to go ahead and stick Fahrenheit on the bottom and Celsius on the top. And what we're going to do here is I'm going to put in 0 degrees Celsius, because that's pretty easy. 0 times 9/5 is 0 plus 32, so I get 32 degrees. Now, since 5 is in the denominator, I'm going to make it 5 here for degrees Celsius. The 5s would cancel, so I'd get 9 plus 32, which is 41 degrees. Again, we're just adding that 9, because this is the 9 that we have. Then if I go to 10 degrees Celsius, the 10 and the 5 will simplify to be 2. So 2 times 9 is 18. 18 plus 32 gives us 50 degrees. That goes down here. Again, that's an addition of 5 degrees. So if I go up by 5 more degrees, I know I'm going to get 59 degrees, because this pattern of adding 9, adding 9, adding 9. So when I look at these, if I have 0 over 32, is that equal to 5 over 41? Well, we know that those are definitely not equal, but we can check a little bit more. We look at 10/50ths. We know that 10/50ths can actually be rewritten as 1/5. And 1/5, well, we know we can't write 5 over 41 as 1/5. I know that if I had 5 over 40, I could actually write 1/8. So again, these are not equal. So we're going to go ahead and call this a non-proportional relationship, because all the ratios need to be equal. Kind of like how we started the problem, they all needed to be equal and be able to be simplified to the same ratio, the same fraction. So is the length of a side, and the area of a square, again, we're talking about area of a square, proportional. So I'm going to start with S here, and that's the length of a side. And the area would be S times S, which is S squared. So let's go ahead and put in 1, and 1 squared is 1. And if I have 2, that's going to be 4. And if I have 3, that's going to be 9. If I have 4, that's going to be 16. Well, is 1 over 1 equal to 2 over 4? And is that equal to 3 over 9? And is that equal to 4 over 16? None of these are actually equal, because 2 over 4 is 1/2, and 3 over 9 is 1/3, and 4 over 16 is 1/4. So none of those ratios are actually equal. So this is a non-proportional relationship. So the length of one side and the area of a square are a non-proportional relationship, because it's actually exponentially proportional, because we have an exponent there. Megamart collects a sales tax equal to 1/16 of the retail price of each purchase and sends this money to the state government. So they take 1/16 of the price, and then they add that on. So for example here, if something costs $16, they're going to take 1/16, which is $1, and they're going to add that back to the sales price. They're going to charge you. That extra dollar, because the store still wants their $16. They're going to charge you $17. $1 is sales tax, but they're going to take that $1 and send it to the state government, and they're going to keep their $16. So we need to kind of think of it like that. So in this case, if we bought something that was $32, that would be 1/16 is going to equal $2. So they're going to take the $32 plus 2, and so the grand total is $34. So they want to know, is the amount of tax collected, so like this one would be the amount of tax collected, proportional to the cost of an item after tax has been added? So is it proportional to the cost of an item after tax has been added? So is the 1 proportional to the 17? Because we know we're taking this ratio of 1/16 out. So, well, for this case, we're going to say, okay, we have 16 and we're getting $1. So I'm going to say 1/17. Okay, so $1 is the tax, and 17 is the 16 plus 1. So if I have 32, $2 is the tax, so I'm going to say 2/34. And then again, we think of multiples of 16, and the next one would be 48. So we're going to get $3 of tax there, so that's going to be 3/51, because the $48 plus $3. And then we'll add 16 again to get $64. So if the sale price was $64, they're going to charge you $4 for tax, so that'd be 4/68 for the total price. So again, the question here is this proportional? 1/17, does that equal 2/34? And does that equal 3/51? And does that equal 4/68? Well, if I were to simplify 2/34, I would get 1/17. And if I were to divide both top and bottom here by 3, I would get 1/17. And if I divide by 4, I would get 1/17. So here they are all equal to this ratio of 1/17. So I would say that this is a proportional relationship. So in this case, we do have a proportional relationship. It's just a little tricky here, the wording of the problem. So that gets us to the end of our examples for lesson 4-2. If you'd like to see some more examples, check out the online tutors. Also, when doing homework, if you have any questions, check out the step-by-step homework helper, which I've also included on Moodle.